Hi everyone, Assalamualaikum. In this video, we will continue with evaluating composite inverse trigo functions using triangle method, right? Alright, we're still under the second topic in chapter 1, which is evaluating inverse trigo function using triangle method, right? Right now, we look at example 4, right? Simplify cosec to inverse tangent 3 over x in terms of x. Now we look at the solution. Okay. First, step 1, let A equals to inverse trigo function. Okay. So now our inverse trigo function is inverse tangent 3 over x. 3 over x comes together with inverse tangent. So we need to let A equals to inverse tangent 3 over x. But to here, we can use double angle identities later. Okay? Alright. So, we let A equals to inverse tangent 3 over x. Okay? After that, we continue with step 2. Okay? Change inverse trigo function to ordinary trigo function. Okay? We move inverse tangent to left hand side. So we get ordinary tangent A equals to 3 over x, right? Right, then we can continue with step 3. Okay? Draw a right angle triangle and determine all the three sides based on the trigo function obtained in step 2 here. Alright? So we draw a right angle triangle with angle A. Okay? From tangent A, from step 2, from tangent A equals to 3 over x, 3 means opposite. So we can put 3 here. Okay? And x equals to adjacent. So we can put x here. Right? After that, we can find hypotenuse using Pythagoras theorem. Okay? Right, so we have x squared plus 3 squared equals to x squared plus 9. So we can put here. Okay, so this is our hypotenuse. Alright. From the previous slide in step 3, we done draw a right angle triangle with all three sides. Right. Then we can continue with step 4. Okay. Find the relevant trigo ratios from a right angle triangle here obtained in step 3. Okay. Right. The relevant trigo ratios means the trigo ratios that we can find to simplify this question. Okay. Actually, from this right angle triangle, we can find all 6 trigo ratios. But to save the time, we can find the relevant trigo ratios only. Okay. From cosec here means cosec to A. Okay, we relate with sine and cos. So we just find sine and cos only from right angle triangle here. Okay, sine angle A equals to 3 over square root of x squared plus 9. Okay, 3 is an opposite. Square root of x squared plus 9 is a hypotenuse, right? And then we find cos A. Okay, cos A equals to x over square root of x squared plus 9. X here means adjacent. And square root of x squared plus 9 means hypotenuse, right? Right, after that, we continue with step 5. Evaluate the given question. Okay, so therefore, the given question is cosec 2 inverse tangent 3 over x. Okay, from step 1, we let inverse tangent 3 over x equals to a. Right, so now we can write cosec 2a. 2 here means we can use double angle identity. Okay, we just let A equals to inverse tangent 3 over x. Okay, 3 over x here means come together with inverse tangent. Okay, that's why we let A equals to inverse tangent 3 over x in step 1. Okay, so we rewrite in terms of A. So we have cosec 2A, right? And then cosec, okay, we can refer reciprocal trigo identities. Okay, cosec means 1 over sine. Okay, cosec A equals to 1 over sine A. So means that cosec 2A equals to 1 over sine 2A. Okay, and then 2 here, okay, means we will use double angle identity. Okay, so from sine 2A in denominator here, we can refer from double angle identities. Okay, sine 2A equals to 2 sine A cos A, right? So we can write 1 over, we replace sine 2A equals to 2 sine A cos A from double angle identities, alright? So now we need to substitute the value of sine A and cos A. Okay. Alright, from step 4 in the previous slide, we get sine A equals to 3 over third x squared plus 9 and cos A equals to x over third x squared plus 9. So we can substitute here. Okay, so now we have 1 over 2. We replace sine 2A by 3 over square root of x squared plus 9 times cos A we replace by x over square root of x squared plus 9. Right? After that, we get cosec 2 inverse tangent 3 over x equals to 1 over, we multiply 2 times 3 times x equals to 6x over, we multiply third x squared plus 9 and third x squared plus 9, so we get third x squared plus 9 bracket square root, then we can simplify square root, so we get x squared plus 9. Okay, no more square root, right? Then after that, we simplify, so we get x squared plus 9 over x. How we get this? Okay, from here, 1 over 6x over x squared plus 9 means 1 per means we divide by 6x over x squared plus 9. Then from division, we can change to multiplication, but we need to exchange numerator and denominator. So we get 1 times x squared plus 9 over 6x. So the final answer equals to x squared plus 9 over 6x. That's why we get this. Right? So this is the final answer. Okay, we simplify cosec 2 inverse tangent 3 over x in terms of x. The final answer we can get in terms of variable x. Okay, because the original question is given in terms of x. Alright. Coming up next, examples involving evaluating and simplifying composite inverse trigo function using triangle method. Right? If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.